Alright, exploring conic sections. Write down the definition. The conic section is a curve formed by the intersection of a plane and a double cone. In your book, there are diagrams of the 4 different types of conic sections, and they're listed right here. You have a circle, a parabola, an ellipse, and a hyperbola. Okay? I'll come back with this if you don't have it down already. Let's look at example 1. The first one, it tells you to graph the circle. Graph the circle of x squared plus y squared equals 25. I'm going to do it differently than the way the book does it. Okay, the book uses a table of values. It's a lot more work. I might be jumping ahead in the book, but I think it's easier to do it this way. It tells you in the first example that this is a circle. It says graph the circle of x squared plus y squared equals 25. Now pay attention to all the equations we're about to graph, because when you get to the 4th example, you'll be asked to identify from the equation what type of conic section it is. So just by looking at this, we should be able to tell that it's a circle. If you have x squared, plus is key in a circle. It's got to be an addition for a circle. And your numbers in front of x and y have to be the same for it to be a circle. And they both have to be squared for it to be a circle. There's only one conic that is not, where one of the variables is not being squared. Which one is it? Think back.
Parabola.
Parabola. An example of a parabola is y equals x squared, right? Only the x squared in that case is being, only the x is being squared. Okay? So you should be able to look at that equation and tell it's a parabola. In this one, graph the circle x squared plus y squared equals 25. Just by looking at it, if there's nothing being added with x or y, your center is 0, 0. In this case, my center is 0, 0. I think in this entire section, for all 4 different conics, the center or the vertex is 0, 0. Then we should be able to find the radius. So you need the center and the radius, then you're fine. What is the radius just by looking at it? 5. How did I get 5?
Square root.
Square root of 25 is 5. That's it. So just go 5 units from the center in all directions, right, up, left, down, and draw your circle. Okay? Then the next thing it asked for was the domain and range. And that's listed below. The domain is your x values, and it's everything in between -5 and 5, including -5 and 5. Same with the range. Y values are between -5 and 5. Easy enough for a circle. Alright? Then the next example tells you that it's an ellipse. Graph the ellipse. Here's the original problem right here. 9x squared plus 16y squared equals 144. I should have known right there that it couldn't be a circle. It has a plus sign, but it can't be a circle because of y.
Because the 2 numbers are
These 2 numbers are different in front of x and y. Okay? But the plus tells you it's an ellipse. If you see plus, you know it's either an ellipse or a circle. If the numbers are different, it's got to be an ellipse. Now, for an ellipse, we want the right side to always equal 1. Okay, so I divide everything by 144 and end up with this. X squared over 16 plus y squared over 9 equals 1. Does that make sense? Because 9 over 144 reduces to 1/16. 16 over 144 reduces to 1/9. 144 over 144 reduces to 1. Okay. Once you get in standard form, you're set. Again, The book wants you to do a table of values. I don't care about that. I like this a lot better. Our center of the ellipse is 0, 0 because nothing's being added or subtracted to x or y. So you put a point at 0, 0. Then you look at the number under the x, which is what? 16. Take the square root of that. 4. They go 4 units right, 4 units left on the x-axis. Now look at the number under the y. 9. What's square root of 9? 3. Go up 3, down 3 on the y. You're set. You're done. Connect those 4 points with your ellipse. And your domain and range, same thing. Domain's from -4 to 4. And your range is from -3 to 3. Now for an ellipse, x and y, x is always going to come before y in the equation. Alright? The hyperbola, x and y can switch. And that's what we'll look at next. Any questions on this? Alright, grab the hyperbola.
Oh my gosh.
Good. The original problem is right here. X squared minus y squared equals 9. That's the original problem. I knew it couldn't be a circle or an ellipse because of the minus sign. Okay. Knew it couldn't be a parabola because both of them are being squared. So it has to be a hyperbola. And same for an ellipse and a hyperbola, we both want both of them to equal 1. So here I'm going to divide everything by 9. So I end up with this in standard form. Okay? X squared over 9 minus y squared over 9 equals 1. Nothing's being added or subtracted to x and y, so my center is 0, 0 again. What do I do on the x-axis? 3 units right, 3 units left. Put a point there, put a point there. Same thing with the y. 3 units up, 3 units down. Put a point here, put a point here. Now with those points,
Wait, why is it 3?
square root of 9.
Okay.
With those points, I make a box. The dotted lines here are not actually part of your graph. We're just using that box and the asymptotes to come up with the curve. Right? So you just take these 4 points and make a box. You see that? And with through the corners of the boxes, you draw your asymptotes, which are here and here. And then I can get a more accurate drawing of what the hyperbola looks like. Since x comes first in the equation, that tells you to open the curve on the x-axis. If y came first, it would open here and here. We would open it along the y-axis. Okay? So, see what the asymptotes do for your graph. That shows you where to open your curve to. How wide or narrow
Do
to
you have
open.
to do that?
Yeah. But that's all you have to do. Again, that's the easier way to graph it rather than making a table. Table to me is more complicated because you got to solve for y, take square roots, plus, minus, and all that fun stuff, and come up with decimals. Yeah.
Are the asymptotes always going to be the same?
Yeah. One's going to be positive, one's going to be negative, but they'll have the same equation. Yes.
No, will they always be the same on the graph as you have there?
No.
How
It all depends on these numbers. Yeah, we'll talk about how to come up with the equation in the next section of the asymptotes. But no, they won't always have the same equation. But they will always go through the corners of the box.
Okay.
Yeah. Once you get the box, you draw the asymptotes, then from there you draw your curve.